Okay, this is the second half of 1.2 for geometry. A postulate or axiom is an accepted statement of fact. And we use these to prove other things in geometry. So postulate 1.1 says through any 2 points there is exactly one line. So to get between 2 points there's only one line that will go through it, not multiple lines. So in this picture, line T is the only line that goes through points A and B. When we have two or more geometric figures, their intersection is the set of points the figures have in common. So in algebra, when we were solving where two lines intersect, they intersect at a single point in this picture. If they're the same lines on top of each other, they have infinitely many points in common. But it's wherever they meet up that we call their intersection. So postulate 1.2 says if two distinct lines intersect, then they intersect at exactly 1 point. So this is talking about two lines that aren't the same line. So we wouldn't say line AE and line AE. So in our picture we have line AE and line DB, and they intersect at the point C. Postulate 1.3 says if two distinct planes intersect, then they intersect in exactly one line. So plane RST and plane WST intersect in line ST, right there. Okay, so if we look at planes ADC, so the top of this cube, and plane BFG, which is the right side, we can see that they intersect at this line right here. So again, here's plane ADC up here in the pink, and plane BFG is on the side in yellow, and we can see that they intersect at BC. Okay, so our got it problem says what are the names of two planes that intersect in BF? So if they intersect in BF, they're intersecting on that yellow line. So two planes that intersect there are planes ABF and BCG. And remember, we use 3 points to name a plane. So those aren't the only planes that you could choose. You could have them called different things. They can have different names. But it will be this front plane in blue meeting up with this side plane in green. They intersect at BF. And got it question B says why do you only need to find two common points to name the intersection of two distinct planes? Well, that's because their intersection is a line, and remember we only need 2 points to form a line. Postulate 1.4 says through any 3 non-collinear points, that means they don't share a line. They're not all 3 on a line. There is exactly one plane. So if you look at points Q, R, and S, we can see that they're non-collinear. They aren't all sharing a line. I couldn't put a line through those 3. And plane P is the only plane where all of those 3 are sharing. Okay, so if we look at this figure, question A says, what plane contains point N, P, and Q? I'll point this out in blue. So here's N, P, and Q. Well, that's the plane on the bottom that we can see shaded over here. We could call that plane NRQ. You could call it a few other things, but we'll call it that. And then if we look in green, What plane contains points J, M, and Q? Well, you can see that shaded in the picture. It's going diagonally down. It kind of looks like a slide. And we could call that JMQ. We could call it JMP. Again, there's multiple names we could call the plane. Okay, our got it question. I'll do in purple. What plane contains points L, M, and N? Copy the figure already. I'm going to sketch it out down here. Or try to at least. So we're looking at points L, M, and N down here. So I'll try to do this in purple here. We're looking at the plane. That would be like the fat slide coming across. And then part B says, what is the name of a line that is coplanar, so shares the same plane, with the line JK and KL? Here, I'll mark in orange. JK's right there, and KL is right there. So if they're on the same plane, it's kind of like they're at the same height. So I could choose line ML and line JM. So JM or ML are both lines that are coplanar with JK and KL. Here's our lesson check. We're just going to do number 3. What is the intersection of two planes? A line. Two planes intersect at a line. And here's your homework.